So use notes on the test. As we go through this, you guys make note of anything you want to put in your notes. So if you want to copy these problems and put them on your notes, that's okay. If they want you to find the roots, they just want you to solve that equation. And because it's a quadratic, there's going to be two solutions, two roots. So you see if you can factor it. Is there anything I can multiply that's going to times and give you 1, but adds and gives you the middle? Is there any whole number or integer that's going to multiply, give you 1, add, give you 1? And the answer is no. So it's not going to be easy. And you can look at the answers. Your answers are not integer solutions. They are looks like they're kind of messy. So that's a hint that you're going to have to use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So identify your a, b, and c. A is the number of your quadratic, how many quadratic pieces you've got. B is how many linear pieces you've got. C is the constant, the number all by itself. So A in this case is 1 because you only have 1 x squared. B is 1 because you only have 1 x. And C is 1. So if A is 1, B is 1, C is 1, just plug them into the quadratic equation. So x equals negative b, negative 1, plus or minus the square root of 1 squared, that's 1, minus 4 times 1 times 1, all over 2 times 1. So my next step is a negative 1 plus or minus the square root of 1 subtract 4 is this minus 3 all over 2. And here is my hint right here. I've got a square root of a negative, so it's going to be an imaginary answer. So right off the bat I can kill C because C is not imaginary. So if you can narrow it down, that kind of helps, but in this case we only killed 1, so it doesn't help that much. So your final answer should be negative 1 plus or minus imaginary square root of 3 divided by 2. That matches up with D. Dang it, it doesn't match up with D. Matches up with B. So that'd be a negative 1. Nice eye. Okay, number 2. Okay, number 2 is asking you to think backwards. If your answers are a negative 3 halves and 6, what would the step before be like? So you got 4 to choose from. You start eyeballing which of those 4 choices is going to match your answer. So this one's going to be easy. Let's start with this. If x was 6, you can kill C and D right off the bat, because I'm going to plug 6 into this. If I plug 6 into A, it's going to be 6 take away 6, and that's a 0. And 0 times this, which would be like 18, 19, 20. So 0 times 20 is 0. So A would work or B would work. So now we got a 50-50 shot. Let's see if we can figure out which one is going to be negative 3 halves. And you should end up a B, because if I plug a negative 3 halves in right there, it's going to be 2 multiplied by a negative 3 halves. And times fractions, you can cross cancel. A 2 on top and a 2 on bottom, that's 1. So 2 times negative 3 halves is going to actually be a negative 3. And then if I plus 3 to a negative 3, there's my 0. Okay, this one. X squared plus 8 is 0. Solve for x. So the fastest, best route, if you've got this, x squared plus 8 is 0, is just to solve for x. If you're missing your linear term, if you have no x's, you just have x squareds and a constant, then I'm just going to minus 8, x squared equals a minus 8. Undo the square, so square root here, square root here. You're going to have x equals, because I took the square root, it's got to be plus or minus. square root of negative 8. Okay, now stop and eliminate some. It is going to be another imaginary. There's your hint. It's square root of a negative, so it's imaginary. So you can kill B and A, and I can even kill C. Why can I kill C? Because C does not have a plus or minus. C only has a plus. So I know right off the bat it's going to be D. And I can prove it because my next step would be this right here. So I'm going to go plus or minus imaginary square root of 8. I'm going to replace square root of 8 for plus or minus imaginary square root of 2 cubed. And then I pull out a pair of 2's, plus or minus 2i, and a 2 stays under. So we get D. This one's probably, I just look at my answers and I know I'm going to have to use the quadratic formula. I can't factor it. There's no number that's going to multiply, give you 2, add, and give you negative 2. So I'm going to find A is 1, B is negative 2, C is 2. So it's going to be x equals negative B. B is negative, so it's a negative B, plus or minus the square root of B squared, a negative 2 squared. You have to put the negative 2 in parentheses if you're using the calculator. Minus 4 times 1 times 2 all over 2 times 1. So my next step is positive 2 plus or minus square root. Negative 2 squared is 4. And this is all going to be a negative 8. So 4 minus 8 is a negative 4 all over 2. Okay, again, I can kill A and B because it's going to be another imaginary square root of a negative. So I know right now well, you can't kill A. A is imaginary, but I guess I can only kill B. So that doesn't help too much. So my next step is going to be it's 2 plus or minus an imaginary times the square root of 4 divided by 2. And you're in luck because the square root of 4 is a perfect square. So it really is 2 plus or minus 2i divided by 2. And you can divide both those terms by 2, so your final answer is going to be 1 plus or minus 1i. Which, if you look at A, B, A, C, and D, you're going to go with D. Okay, multiplication. This is just a distributive property. Negative 2 times 4 is negative 8. Negative 2 times negative 2i is plus 4i. 3i times 4 is 12i. And then 3i times a minus 2i is a minus 6i squared. Combine these two middle terms, and you're going to have a total of negative 8 plus 16i minus 6i squared. And then all you know about imaginaries is an imaginary is the square root of a negative, but an I squared is equal to a real number, negative 1. So you are going to swap out this I squared. It's going to be a negative 6 times a negative 1, which is a positive 6. And then you're going to mate these two, a negative 8 and a positive 6. You should have a negative 2 and a 16i. So, what one is that? C? Okay, which of the following are not real? Pi, so number 1 is pi, that is real. So, I can kill A and D because they both have 1. Now I got a 50-50 shot. Number 2 is obviously not real because it's got an imaginary. So I can kill C. And I know it has to be B because that's the only answer that has something that's not real. And the other one that says is not real is 3. And 3 is because not real because square root of a negative 3, that's imaginary. the inverse. So there's 4 steps to find the inverse. Step number 1, so if we copy y equals 3x minus 2, step number 1, just interchange your x and your y. So I'm gonna say that's the x and that's the y, and then you just solve it for y. So you're just gonna undo the subtraction first. Plus 2 plus 2. So you should have x plus 2 equals 3y. Now undo the multiplication. Divide by 3, divide by 3. And we should end up with x plus 2. That whole thing divided by 3. So that matches up best with B. Find f of 3. All they want you to do is substitute into the function f the value 3. So you're going to replace, there's 2 spots where you're going to have to sub it in. So it's 3 times whatever you sub in squared minus 2 times whatever you sub in. So these were where my x's were, and I'm just going to drop in place of those x's a 3. So you do the exponents first. You have to do the 3 squared, so that's 9. So that's 3 times 9 minus 6. That's 27 minus 6, 21. B. Okay, it becomes a little bit more abstract now. So they want you to do a composition. This is the same thing as G compose F. So they're gonna ask you to take the function f, and they give it to you right here. So they don't want you to substitute in a number, they want you to substitute in an algebraic expression. So you're gonna take f and you're gonna sub it in to G. So G says this, 2 times whatever you sub in minus 1. And I am gonna sub in the entire function of f, which is x plus a 3. And now you just do the arithmetic. Do the distributive property, so times both those by 2. So it's going to be 2x plus 6, and then at the end you got a minus 1. Combine your like terms, and you should end up with 2x plus 5. So D. Okay, this one's even trickier. So it's F compose G compose H. So they want you to start with H. Start with your innermost, plug that whole thing into G, and then plug that whole thing into F. So H is actually, it's actually kind of a nice one. H is just X. So you're going to take that expression of H and you're going to plug it into G. So G says this, 2 times whatever I plug in minus 1. And if I plug in H, if I take this X and plug it in there, it's really not changing anything. You're still going to end up with 2x minus 1. But now you got to take this 2x minus 1 and sub it into F. And F says whatever you plug in, all you do is add 3 at the end. So I'm going to plug this in, 2x minus 1, and then add 3, and I should end up with 2x plus 2 for your final answer. So that's C. Okay, the range is all of your y's. So possible questions, here's what we could ask you. X's are domain. Y is the same thing as output. X is the same thing as input. So if I ask you to look for any one of these 6 things, I'm not going to ask for X's or Y's. We'll probably ask for input, output, domain, or range. So the range is going to be all of the 2, the 4, the 6, the 8. But another question that could show up is I'll ask you, is that relation a function? Or does each input give you only one output? This relation is a function, but what if I put this next ordered pair in. What if I put 3, 6? So now you got 5 data points. 1, 2, 3, 4, 5. And I say, is that relation a function? And the answer is no. Because 3 always should give you a 4. But then at the end they plugged in 3 again and it gave you a 6. So if you plug something in and it gives you 2 answers, it is not a function. Okay, this is asking you simply to do addition. They want you to take f and add it to g, and you could see it like this: f plus g of x. These are the same thing, but the key word is addition. All they want you to do is add them. So the rule for f says 3 times x squared plus 2x, and then I'm going to add the rule of g, which is 5x squared minus 8. So it's just combine like terms. But f is kind of tricky because it's not cleaned up. You're going to have to distribute the 3 first to both those terms. So it's going to be 3x squared plus 6x plus 5x squared minus 8. Combine your x squareds. You should have a total of 8x squareds. That's it. Plus 6x's minus 8. So that matches up with D. And that's it, right?